Hey everyone. So today we're going to talk about the three states of matter. So when we are talking about matter, matter is something that takes up space and weighs something. So when we're looking at the states of matter, we usually say there are three states of matter. Number one, things are solid. That means that they are they're not able to change shape. So for instance, my slime container, I can't change it. But now on the inside, the slime is kind of liquidy. So when we say that something's liquid, it means that it can change shape. If I was to pour my slime all the way out, which is slowly doing, it's going to change shape. And it's going to change the shape into whatever I want it to do. So if I have a different container, I'm going to have my slime, my liquid go into that, and it's going to take the shape of that. Lastly is gas, and gas is like the air around you. So you can't really see it. Um, and it and it can happen sometimes when we heat up a liquid, or when just the oxygen outside is just air. It's just a gas that we have to be able to breathe. So we can change our a lot of materials by heating or cooling, and it'll change into a solid liquid or gas. So for instance, if I was to take my soda, and right now it's in liquid form, but if I was to go put the soda in the freezer, then it would turn into a solid. But if I was to put the liquid or even the solid onto the stove and heat it up to boil it, then it would evaporate and turn into a gas. And we're going to talk about what those three states are later on in this video as well. So, first, when we are becoming scientists and we're determining how we should talk about the the three states of matter, we have to first look at the properties or the physical properties. What can I see? What can I touch? What can I hear? What can I taste? And let's see, did I miss one? I know I missed one. What we see, what we taste, what we smell, there we go, and what we hear. So we have all five of our senses there, and we're trying to figure out how we can describe the item that we have. So, for instance, if I am trying to describe my slime, I might say that it's kind of thin, it's sticky, it's yellowish green, it's shiny because it is kind of shiny, and then I would say that it's a like liquid, and that the shape changes. So right now it's in a cylinder, so it's cylinder shape. So if you look over to the right side of your screen, you can see a lot of different adjectives that we use to describe the physical properties of an object or a piece of matter. So let you take a look at those real quick. So we can say things are bumpy. We can tell what color it is. We can say, is it long or short? Is it light or heavy? Some people even use, it's as light as a feather. So matter is something that takes up space and something that weighs an amount. But what is mass? Well, mass is just how much does something weigh? And what do we use to check the weight of something? We use a scale or a balance. Now, when we're talking about how much does something weigh, we use different measurements. And we use these measurements so that everyone in the world will know how much we're talking about. So let's say that we're using grams. Grams is what we use to measure really, really light objects. So for instance, if we had a paper clip is about 1 gram. Now, if I wanted to weigh something a little bit heavier than a paper clip, I might use kilogram. And kilogram is, let's say it's about the size of a book. Okay, so if I was to pick up a book, I would say that the book is about 1 kilogram. And we say kilograms because it takes 1,000 of those little bitty grams to make up a kilogram. So for visual representation, think of it like this. There's 1,000 paper clips. 1,000 paper clips will equal 1 kilogram. Pretty nifty. We can also use pounds and ounces, but here's the deal. In the United States, we use pounds and ounces quite a bit, but the rest of the world, they don't use pounds and ounces very often. So, well, they'll use ounces, but they won't use pounds. They'll use grams and kilograms more. So, what would we use for pounds and ounces? Well, a pound, think of a loaf of bread. A loaf of bread is about 1 pound. And for an ounce, 1 ounce is equal to about a slice of bread. All right, we're going to watch this video with Moby and Annie, and we're going to learn about how we use weight. Here we go.
Let's see, this weighs about, hey, I was trying to weigh that apple. What is weight? Weight describes how heavy something is. Some things are heavy and weigh a lot, while other things are lighter and weigh less. You can use a balance to compare the weights of different objects. The side with the stapler moves down. That means the stapler is heavier than the eraser. Right, Moby. The stapler is bigger than the eraser. But just because something is bigger, it doesn't mean it has to be heavier. Which ball is heavier? The beach ball is bigger than the baseball, but it's lighter. What are ounces? An ounce is a small unit of measurement. A slice of bread weighs about 1 ounce. A scale is a tool that measures weight. Let's see. That pear weighs 10 ounces. We use the abbreviation OZ to stand for ounces. You can use ounces to measure light things like a banana, a potato, or a pepper. What are pounds? You can use pounds to measure heavier objects. A loaf of bread weighs about a pound. The broccoli weighs 1 pound. We use the abbreviation LB to stand for pound. 1 pound is equal to 16 ounces. That means your broccoli weighs 16 ounces. Let's see. This pineapple weighs 5 pounds. We use the abbreviation LBS to stand for pounds when it's plural. You can use pounds to measure heavier things, like cauliflower, eggplant, or carrots. That pumpkin weighs 8 pounds and 1, 2, 3, 4 ounces. You can count the tick marks to count the ounces. The world's largest pumpkin is over 1,000 pounds. What are tons? To measure really heavy things, you can use tons. A small car weighs about 1 ton. 1 ton is equal to 2,000 pounds. So that means a small car weighs about 2,000 pounds. The largest living animal on Earth is a blue whale. It can weigh about 150 tons, which is equal to 300,000 pounds. When you weigh things, decide which unit of measurement makes sense. It doesn't make sense to weigh crayons in pounds or tons. You should weigh it in ounces because it's light. If you want to weigh yourself, you could use pounds and ounces.
All right, so now that we've seen Moby and Annie go through the grocery store and use pounds, ounces, and tons, we can go on, there we go, to our check of our knowledge here. So, which one is heavier? Is it the beach ball or is it the goldfish, the container with the goldfish in it? Which one is lighter, the pillow or the safe? Which one is lighter, the leaf or the fruit, the plum? Which one is lighter, the frog or the flower? All right, now that you've put your answers in, we are going to double check and see what we got right. So the goldfish in its water is heavier than the beach ball. The pillow is lighter than the safe. The leaf is lighter than the plum. And the flower is lighter than the frog. How did you do? All right, now it's time to check your knowledge. Which is a better estimate for the weight of an egg? Is it 2 ounces or 2 pounds? Which is a better estimate for the weight of a loaf of bread? 1 pound or 1 ounce? Which is a better estimate for the weight of a robin? There's a picture of the robin there. Is it about 2 ounces or is it about 2 pounds? Which is a better estimate for the weight of a bunch of bananas? Would you say it's 29 ounces or 29 pounds? And which is a better estimate for the weight of a bath towel? Is that going to be about 1 pound or 1 ounce? Now, remember, these are just estimates. So think about your best guess. Look at the other items and see if there's any that could be similar. Now that you've had a chance to put your answers in, let's check to see how you did. An egg is about 2 ounces. It's pretty light. A loaf of bread is about 1 pound. A robin is about 2 ounces. They're very tiny birds. Bananas, oh, I hope you never get 29 pounds of bananas unless you're a chef or something. 29 ounces is plenty for your house. And then a bath towel is about the same as a loaf of bread. It's about 1 pound. Hopefully you did really well on that. All right, so let's talk about the states of matter. So we've already talked about how matter changes. When we look at our picture here, a solid has these particles inside of it, and you can't really see it. But this is a diagram that kind of shows what the particles may look like. If you notice in a solid, they're really tightly packaged. And in a solid, they're going to vibrate, but they can't move because there's so many of them packed into that piece of matter. And a solid is going to retain their shape unless we heat it up or cool it. So like for instance, if I heat up my slime, my container that holds my slime, if I heat it up, the container might melt because it's plastic. However, if I was just to leave my slime container on the table, it's not going to change. Now the liquid, The particles in a liquid are close together, but they don't have a pattern like the solids. So that means that if I change the container that the liquid is in, it's going to change its shape. So if I pour water into a cup and then pour my cup of water into an ice cube tray, it's going to change the shape from going free form from the faucet, putting it into a cylinder shape in a cup, and then a rectangular cube when I put it into the the ice molds that would go into the freezer. Now, gas, their particles are well spaced apart, and there's no pattern in those at all. And when they vibrate, they do so at a high speed. Now, one thing about gas is that you can have a gas and put it in a container, and it's going to take up that same shape. So if you've ever gotten a balloon blown up at a store like Walmart or Dollar Tree or even at Kroger. So you go in there, you say, "Hey, I want this balloon blown up." They go over to a canister and they put the balloon on top and they release the gas from the canister. So the big canister has gas that flows into the small balloon and it takes the shape of the balloon. So remember that a liquid can take the shape of a container that it's in. So we have ocean and cooking oil, honey, and lava. Those are all kinds of liquids. And we might say that a liquid is bubbly. It could be foamy. It could be transparent, translucent, or opaque. So transparent means that I can see all the way through it. Translucent means I can kind of see through it. And opaque means I really can't see through it. So here are some examples of gases. Gas is another name for vapor. So if you hear vapors and gas are the same thing. They're synonyms. So when I'm looking, you can describe a gas as being heavy or light. You can say that they're odorless or they have some kind of odor. That's a smell. Or they're clear and transparent. So here are some examples of gas. We have the atmosphere. So like when you're moving your arms around, that's your atmosphere. That's the oxygen around you. When you pour a glass of soda and there's bubbles in it, that's gas. When a volcano is sending up little smoke, that's a gas. That's a fume or a vapor. Then the helium in the balloons like we talked about. And then in the canisters here, there's gas inside of those. And if you notice, I'm not talking about like the gas that goes into your car. That's actually a liquid. It's kind of funny that it's called gas, huh? And then our clouds. Now, our clouds are actually large amounts of water droplets, and they're really, really tiny, but they form a gas. Okay, here we go. We have solids. So all of these things are solids, and you can describe how they feel, smell, what their shape is, what their texture is. And you can even talk about their taste as long as you know that it's safe to eat. So there's a solid ice, there's a chair that's solid, there's a mountain, some bones, an avocado. Even the avocado, the meat of the avocado, the yellow and green stuff, that's a solid. It doesn't change the shape unless you break it apart. And then the pit or the seed is a solid as well. And the skin is a solid. And then there's a tree. All right, time to test your knowledge again. Is a coin a solid or a liquid? Go ahead and put your guess in. If you said solid, you got it. What about grape juice? Is that a solid or a liquid? If I was to pour that juice out, would it change the shape of the juice? If you said yes, you're right. It's a liquid. What about wet glue? Is glue a liquid or a solid? It's a liquid. When I take it out of that container, it changes the shape. Sweat. Is that a solid or a liquid? If you said liquid, you got it. The air inside of a balloon, is that a solid, liquid, or gas? Definitely a gas. There's a door. Is it a solid, liquid, or gas? You got it. Oh no, the air inside of a raft. Would that be solid, liquid, or gas? Pretty sure that it's a gas. The air inside of a soap bubble. So not the soap bubble, but what's inside of the soap bubble. Yep, you got it. Air is always a gas. Which property do these two objects have in common? A melted marshmallow or a rubber toy. I love those little rubber toys. Are they stretchy or are they rough? If you said stretchy, you're right. Let's look at this. Bubblegum, tape, and caramel corn. Is it hard, slippery, or sticky? Can I say that bubblegum is hard? Is tape hard? Is caramel corn hard? Are bubblegum, tape, and caramel corn all slippery? Or are they all sticky? Sticky it is. All right, guys. So what you're going to do is you're going to turn in this Ed puzzle video by submitting, and then you are going to turn in your science kit number 1 worksheet. Remember to go around your house and find an object that is smooth, and then write it here. Once you find out, write down the object's name, tell me the color, the shape, and the weight and length. Now you've got a ruler inside of your school bag that can help you with that. And the weight, if you don't have something that can weigh it, you can just say that it's heavy or it's light. All right, so this will be found in your science notebook or your science folder that you got from our back to school bash. And if you don't have it, this is also on our Schoology page. All right, guys. Hope you all have a great day. Thanks for staying here with me.